Hello class, this is the video for multiple dosing. I just wanted to warn you, this is a little harder material than compared to rest of the classes. So the video may be a little longer, but I hope this will help you. First, some of the term we have to remember. One, some of the term you will know. Sometimes it's called fluctuation and accumulation. We'll know about accumulation factor. We'll know about average plasma concentration, which is very similar to what you have seen like CSS. And we'll learn about Cmax at steady state. We'll also learn about Cmin. And we'll learn some of the concept. New concept is dosing interval, dosing rate, and the fluctuation that occurs between maximum and minimum concentration at steady state. So first I wanted to go over this fluctuation concept, fluctuation and maximum minimum. Think about you have administered a drug. This multiple dosing. We are talking about multiple IV dosing, not oral or other thing, multiple IV dosing. So you have administered a drug, the concentration will go down after the dosing interval. You administer another dose, concentration will go up and go down. If you continue to administer the dose, the fixed dose, you will see drug concentration will fluctuate between a maxima, which we call Cmax, and there is a minima called Cmin. So if you continue administering drug, after certain time there will be no more accumulation. Then concentration is going to fluctuate between maximum and minimum. And this concentration is called steady state. Unlike constant IV infusion, there was a steady state concentration like this. But here, in case of multiple dosing, steady state fluctuate between a Cmax and Cmin. But there is an average concentration. This is called, we call this C average. When there is infinity, that means it is at steady state. So this C average is very much equal to CSS and steady state infusion. So here, this is what it is written in these slides. Fluctuation. Peak appears at the time of dosing, and trough, if you think about this peak, trough. So at the time of dosing you will have peak, and then the time before the next dose it will be a trough. Accumulation occurs after successive dosing, and only accumulation will occur when you have some dose drug, you administer a dose when some drug still remains in the body, previous dose. And steady state in drug accumulation, and the peaks and troughs do not change due to additional dosing. Here you have seen this. At steady state, drug accumulation do not increase. It remains steady, and that's why it's called steady state. And it will fluctuate between Cmin and Cmax. Average plasma concentration. Here, this is average plasma concentration. This is the average plasma concentration. In fact, you can calculate average plasma concentration based on Cmax and Cmin. So these are two terms: Cmax, Cmin, average plasma concentration. Average plasma concentration is very similar to steady state plasma concentration. Only difference is, in this case, there is no concentration, fixed concentration. Concentration is going up and down, up and down. So this is the major difference between multiple dosing, steady state of multiple dosing, and steady state of constant IV infusion. some other factors. This is a new term. It's called dosing interval. Dosing interval is inversely related to drug accumulation. That means reduced dosing will increase drug accumulation. Reduced dosing increases, reduced dosing interval, increased frequency will increase drug accumulation. Drug half-life is directly related to drug accumulation. So we have learned that when we have longer half-life, the drug accumulates more. We have learned in constant IV infusion. Short half-life reduces drug accumulation. That means drug accumulation depends on this ratio, T half divided by tau. This drug accumulation depends on this ratio, half-life divided by tau. Then equation that will give you an idea about drug accumulation is RSCC is equal to 1 over 1 minus e to the negative k tau. You remember this? This is a tau, not t. So all you have to remember, this is different. T here is the dosing interval, and this RSCC's new factor is called accumulation factor. Accumulation factor you express by this equation. You can calculate accumulation factor if you know elimination rate constant and dosing interval. And as I have mentioned, drug accumulation depends on drug half-life. You have learned it. Major accumulation occurs when we have long half-life drug. For example, here in this case, when T half divided by tau is greater than 1, you will have major accumulation. This calculation we will do during the class. When T half divided by tau is smaller than 1, drug accumulation will be negligible. So this concept you have to remember. We already know this thing, that long half-life drug will accumulate more, short half-life drug will accumulate less. And if you know the drug accumulation factor or accumulation index, you can calculate Cmax or concentration at any time. Concentration at any time using this equation. If you can calculate Cmax, if you know RSCC, if you know concentration at the first 0 time, it will give you Cmax. And also you can calculate Cmin. If you know RSCC, you know the C at the end of the interval immediately before the dosing, it will give you Cmin. There are one more equation to calculate Cmax and Cmin. We'll come back to that later. And equation for the average concentration. You see, this average concentration is different from steady state concentration. If you say CSS, we can calculate how? That R is equal to CSS times CL. Here, this R and dosing interval is same. So this is my dosing. This is dosing rate. So here you can calculate C average. This R is nothing but dose by tau. So from this equation you can calculate C average, dosing rate divided by CL. And dosing rate, remember, dosing rate is something different from infusion. Infusion rate, we already know what is the infusion rate. In case of dosing rate, you divide dose by dosing interval. So dose, if you have 300 milligram of drug every 6 hours, then dosing rate would be 50 milligram per hour. Remember, dosing rate has a time component and a mass component. Dosing rate, but dosing interval is only time. Dosing interval is like 4 hour, 6 hour, 8 hour, 12 hour, 24 hour. These are called dosing interval, but dosing rate is the mass per hour. For in this case, 50 milligram per hour. So you have to remember this. Now, how you can calculate what fluctuation depends on what we have learned before. The accumulation depends on this, fluctuation just depends on the reverse of this, tau divided by t half. Tau divided by t half. Fluctuation depends on the inverse of accumulation. And here is another equation to calculate maximum minimum. You go over this equation. If you know the Cmax, remember this sign, infinity, this sign, that means C mean at steady state. This is C mean, C max at steady state. This sign always remember. For example, C average, when is this? That means concentration at steady state. You can calculate if you know the Cmax, and if you know the dose interval and K, you should be able to calculate C mean. I will show the calculation tomorrow's class, day after, and also I will post a video on assignment. So no worries, you'll get it. So now another concept I wanted to remember, C average. One, you may think, okay, here I have a C max and C mean. Why can I not just take C max plus C mean divide by 2? Why can't I just take arithmetic mean of this? Would it give the C average? No, it's not going to give you. It will give you an idea, but it's not going to give you exact C average, because when the concentration, this C max, the reason it is not going to give you, because when during this time period concentration continues to decline, because concentration decline in exponential fashion. Here, if you go back to this, if you take you see, this is your Cmax at steady state, it is your C mean. If you take average of arithmetic average, your arithmetic mean would be here, but your real C average is down here, because during this time drug concentration will continue to fall. So arithmetic mean is not going to give you the exact average. To calculate exact average, you have to use a complex equation like this, which I will explain to you later. You have Cmax minus C mean, and then this log will take into consideration of the exponential fall. So bottom line is, if you take mean of Cmax, C mean is not going to give you exact C average. For C average, you have to use another equation, either this one or that one. And then let's go back to the questions. How steady state concentration multiple dosing is different from constant IV infusion. Constant IV infusion, as I mentioned, constant IV infusion, it is always constant, but steady state concentration in multiple dosing, it fluctuates between a minimum and maximum. What are the factors influence drug accumulation? Drug accumulation, two factors: half-life, T half, and tau, dosing interval. So it depends on ratio of T half divided by tau. How drug accumulation related to the dosing interval and drug half-life. This is how it is related. T half by tau is greater than 1 will be major accumulation. T half divided by tau will be elimination, will be negligible. Here tau is dosing interval, RSCC is accumulation factor. RSCC is accumulation factor. How dosing rate is related to infusion rate. Dosing rate is same as infusion rate. In case of dosing rate, you calculate dose divided by tau. Infusion rate, we know R is equal to something like milligram per hour. Same is dosing rate, same as infusion rate. For example, if you have a dose of 300 milligram, and then you have a dosing interval of 6. The dosing rate will be 50 milligram per hour. And then how dosing rate and dosing interval are related. Dosing rate is milligram per hour. Dosing interval is 4 hours, 6 hour, 8 hour, 12 hour and 24 hour. How can get an idea about the degree of fluctuation? Degree of fluctuation, if you take Cmax by Cmin, the ratio of Cmax and Cmin, it gives you an idea about degree of fluctuation. Which equation would you calculate to Cmin and Cmin? There are two equations. One, if you know RSSE, another you can use using elimination rate constant and tau. Why you cannot use mean of Cmin and Cmax as C average? Because Cmin and Cmax is not going to give the average arithmetic is not going to correct C average, because drug falls during the dosing interval in exponential fashion. So you see, I have now 16-minute video, but I hope it helps. I'll go over this material again, and thank you. Please leave any comment you have. If you don't like anything, you just don't be afraid to make comments. If it is something hurt my feeling, that's okay. Thank you.